How Internet infrastructure works. One of the greatest things about the Internet is that nobody really owns it. It is a global collection of networks, both big and small. These networks connect in many different ways to form the single entity that we know as the Internet. Since its beginning in 1969, the Internet has grown from 4 host computer systems to tens of millions. However, just because nobody owns the Internet, it doesn't mean it is not monitored and maintained in different ways. The Internet Society, a non-profit group established in 1992, oversees the formation of the policies and protocols that define how we use and interact with the Internet. In this article, you will learn about the basic underlying structure of the Internet. You will learn about domain name servers, network access points, and backbones. But first you will learn about how your computer connects to others. The Internet Computer Network Hierarchy. Every device that is connected to the Internet is part of a network, even the one in your home. For example, your computer may use a cable or fiber modem to connect to an Internet Service Provider (ISP). At work, your device may be part of a local area network (LAN), but your Internet connection is provided by your employer's ISP. Once you connect your computer, it becomes part of your employer's network. The ISP may then connect to a larger network. The Internet is simply a network of networks. Large communications companies have their own dedicated backbones, always-on connections to the Internet that have enough bandwidth to allow many people to use the connection at the same time. In each region, a company has a local office that connects local homes and businesses to its main network. The amazing thing here is that there is no centralized network. Traffic travels from point to point, and if one computer drops out of the network, the packets that make up a digital file are routed to another computer. Files arrive as expected, and you'd never notice the change in the traffic pattern. Internet network example. Here's an example. Imagine that Company A is a small firm that has its office network set up with a server and a networked printer. Imagine that Company B is a corporate ISP. Company B builds or leases office space in major cities to store its servers and routing equipment. Company B is so large that it runs its own fiber optic lines between its buildings so that they are all interconnected. In this arrangement, all of Company A's customers can talk to each other, and all of Company B's customers can talk to each other. But the two companies' networks aren't linked. Both companies can communicate internally, but neither can communicate with the other. Therefore, Company A and Company B both agree to connect to Internet Access Points, or IXPs, in various cities. The two firms' networks can now connect to each other and other organizations using the Internet. This example shows how two companies' networks talk to each other. But these two businesses are just a close-up example showing how their two networks join the vast Internet. To get a bird's-eye view of what these interconnected networks look like, take a look at Barrett Lyons' OPT project, which endeavors to create an evolving map of Internet pipelines. The function of an Internet router. All of these networks rely on IXPs, backbones, and routers to talk to each other. What is incredible about this process is that a message can leave one computer and travel halfway across the world, through several different networks, and arrive at another computer in a fraction of a second. The routers determine where to send information from one computer to another. Routers are specialized devices that send your messages and those of every other internet user speeding to their destinations, along thousands of pathways. A router has two separate but related jobs. It ensures that information doesn't go where it's not needed. This is crucial for keeping large volumes of data from clogging the connections of innocent bystanders. It makes sure that information reaches the intended destination. In performing these two jobs, a router is extremely useful in dealing with two separate computer networks. It joins the two networks, passing information from one to the other. It also protects the networks from one another, preventing the traffic on one from unnecessarily spilling over to the other. Regardless of how many networks are attached, the basic operation and function of the router remains the same. Since the internet is one huge network made up of countless smaller networks, its use of routers is a necessity. Internet backbone. The National Science Foundation, NSF, created the first high-speed backbone in 1986. Called ENSFnet, it was a T1 line that connected 170 smaller networks together and operated at 1.5 megabits per second, million bits per second. IBM, MCI, and Merit worked with NSF to create the backbone and developed a T3, 45 megabits per second, backbone the following year. Backbones are internet connections that allow vastly more traffic than the connection from your home to the central office around the corner. In the early days of the internet, only the largest telecommunications companies had the ability to handle that sort of bandwidth. Today, more companies operate their own high-capacity backbones, and all of them interconnect at various IXPs around the world. In this way, everyone on the internet, no matter where they are and what provider they use, can talk to everyone else on the planet. The entire internet is a gigantic, sprawling agreement between people to intercommunicate freely.